Now that we've covered all the tools necessary to find the zeros of a polynomial, let's talk about our overall process to find all the zeros of a polynomial. So if we're starting off with a polynomial, the first question we should ask ourselves is this quadratic? If so, it's really easy to finish either using factoring or the quadratic formula. Okay, so if we can ever get to a quadratic, we know we're just about done. But if it's not quadratic, then we have to think, okay, has someone told me one of the zeros? Like in a previous problem, we were told, hey, by the way, x equals 2 is a root, so use that fact. If we're told that, great, use synthetic division, then continue with the result of that synthetic division. But if we're not told that, we have to go to something even less pleasing. Could we factor that polynomial ourselves? Maybe like in this original one, where we talked about pulling out that factor of x, and maybe that made it easier. If we can do that, that's great. If not, maybe we can do it by graphing. Okay, if you look back on our previous examples, we have tried an example where we graphed it and saw what happened, and then divided by what we saw in the graph. However, sometimes none of those things so far have worked. If all else fails, right, nothing is working and we're forced to move on to another option, that, and only that, is when we use the rational solutions test. So it's kind of our last resort, right? If nothing else is working, then we use the rational solutions test to come up with the list of potential rational roots, and you just try them until you find one that works. Once you find one that works, you use that synthetic division, you have a simpler polynomial, and you start the process all over again. Okay, so that's kind of our thought process as we're going through finding all the zeros of a polynomial. I want you guys to start this one out here and see what you can do finding all the zeros of this polynomial. So go ahead and pause the video, give it a try, and if you get stuck or if you want to check your answer at the end, unpause and see what I did. Alright, so let's start asking ourselves those questions. So the first question I should always ask myself is this quadratic? Nope, it's degree 3. Was I told any zeros of the function? No. Can I find any by factoring? Yeah, no, I don't see any good way to factor this. Or maybe by graphing. Well, I'm less sure of that. So let's go ahead and take a look at the graph then. So our function is, let's go ahead and clear things out, 7x cubed plus 36x squared plus 54x plus 7. Now notice, they don't tell me to round my answers, so I better hope I'm getting exact numbers here. Let's see what happens. Okay, there's some kind of zero there. Let's see where it is. I'm going to use the zero feature. So I'll pick something to the left of that zero, something to the right of it, and I'll give it a guess. Darn, I have no idea what that number is. Okay, so the only one that even shows up on my graph is not an exact number. So it looks like that's not going to work either. I couldn't use factoring, I couldn't use graphing to get an exact number. So my only option now, my last resort, is to use the rational solutions test. So let's go ahead and try that out. Okay, if you're just getting to this point for the first time, try out the rational solutions test for yourself. Right, come up with P and Q. Think about all the options for plus or minus P over Q. Try them out till you find one that works. Okay, so if you're at that point, go ahead and pause the video, try that out, then unpause and pick up from there. So my options for P would be the factors of 7. My options for Q would be the factors of 7. So my options for plus or minus P over Q would be 1 over 1, 1 over 7, 7 over 1, and 7 over 7. But it is worth pointing out, 7 over 7, that's the same as 1 over 1, so it's kind of redundant. So I have a total of 6 guys I might need to try here, but I'm really just going to keep going till I find one that works. So I could try 1, I could try -1, I could try 1/7, I'll just spoil it for you. None of those guys work. Let's try the first one that does actually work, just to see if we can make sure we know how to do it. So I'm just spoiling it for you. -1/7 is the first one that works. So add down, multiply diagonal. Add down, multiply diagonal. Add down, multiply diagonal. Add down, sure enough. Oops, I don't know why I wrote 0 down there. That should have been 7. Sure enough, I ended up with a remainder of 0, which tells me -1/7 does work. So what I just found out about my polynomial is that x equals -1/7 is a root. In other words, x minus -1/7 is a factor. And when I divide by that, I get 7x squared plus 35x plus 49. So at this point, I should start my process all over again with my new polynomial. But this guy's quadratic. And as soon as I get a quadratic I know how to finish, I use quadratic formula. Okay, if I had seen how to factor, I could do that. I don't really see how to factor. So instead, quadratic formula, let's see what that gets me. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's see what happens with all of that. Kind of messy. Okay, so if I put this in the calculator, 35 squared minus 4 times 7 times 49, let's see what happens with that. Right, definitely not something I want to try to do by hand or in my head. So I'm ending up with negative 147. And from here we can simplify that a bit more. So let's go ahead and take a look at that square root of negative 147. I could rewrite that as, well, let's go ahead and pull out the negative 1. But 147 could be written as 49 times 3. So I've broken this apart into some pieces. Well, the square root of 49 is 7. The square root of negative 1 is I. And I can't do anything with the square root of 3. Well, now let's break this apart into two fractions and try to simplify each one. Well, in my first fraction, I could notice that I've got two numbers that are multiples of 7. So if I divide the top and bottom by 7, I've got negative 5 over 2. And for this one, 7 over 14, that's 1 over 2. So I could write it like this, or I could combine it into one fraction. Either way though, here's two of my solutions, negative 5 over 2 plus or minus I root 3 over 2. And my other solution that I found earlier was x equals negative 1 over 7. So in total, I've got three solutions. Here they are. So let's recap all the things that had to happen in this problem. At the beginning, I tried to see, is this quadratic? Nope. Was I told any zeros? Nope. Could I find any zeros by graphing or factoring? No. The only reason I used the rational solutions test at all is that none of my other tools were available to me. So as a last resort, I used the rational solutions test. Okay, that allowed me to find one solution eventually, which was x equals negative 1/7. With synthetic division, I divided that out. Now I have a quadratic. So I start my process over with that quadratic, and I do know how to solve quadratics. Just use the quadratic formula there. Okay, so again, just to reiterate, the rational solutions test is great when we need it, right? If nothing else is working, this can jumpstart our process and get us moving. But if something else easier is going to work, we should do that something else first. It really is only as a last resort that we use the rational solutions test to get us moving.